So, hey guys, welcome to this talk on Fuzzing 101. My name is Kushal, and I'm a security researcher at Fortinet's FortiGuard Labs. And my research areas are mainly fuzzing, 0 days, pen testing, forensics, OSINT, malware, anything to do with security, and anything except compliance, because I think that's for a later age when I'm outdated. So, Hall of Fames, I found bugs in many products, most of the products that you guys have used or are going to use. So, yeah. And I'm an alumni of RIT, Rochester Institute of Technology, where I did my master's in security and did my bachelor's in computer science back in India. You can reach me on Twitter at Coach0Zone, or you can reach me on LinkedIn. And yeah, so that's basically that. So what is fuzzing? By the way, guys, I'm going to try to make this interactive. So if you have a button on your keyboard for disabling or enabling the microphone, you can do that and just answer. Since I'm going to make it interactive. So fuzzing. So what exactly is fuzzing? It's just a dynamic approach to find bugs, find vulnerabilities, and the way you go about it is that you have an application, a target, and you just send any kind of malformed or modified or random garbage data to that, and hope to make it crash. And when it crashes, you just try to figure out if that's something that's exploitable or not. Is it trying to read some other external memory, write something else, corrupting the heap, or something like that? So that's basically the focus. That's for file formats. If you're looking into protocol fuzzing, then denial of service is also a big thing. If you're able to send some packets and crash some PLC or some other networking device or some microcontroller or something like that. So that's that. Why do we need fuzzing? Because most of the times, if you are in the industry, in software, in IT, actually, there are only two kinds of roles most often. In that is development or testing. So for developers, you develop stuff. For testing, you have all sorts of testing: unit testing, regression, stress, performance, functional, all sorts. But the main problem is that when you're testing, you only have a particular scenarios or edge cases that you're going to be focusing on, and you won't be thinking out of the box. So because of that, and the focus is only for seeing if the application is working properly, not if the application breaks and it could lead to something else. So that's where fuzzing kicks in, and the purpose is to find exploitable bugs, and the input that you send is unlimited. It's not limited to a particular few cases only. So that's the main primary difference. Um, Types of fuzzers. There are three types of fuzzers that people normally use: mutation, generation, and evolutionary. In layman terms, I just call it dumb, smart, and someone who thinks they're extra smart. So mutation based, you're just modifying, playing around with the binary, and you are just bit flipping or byte flipping. Generation based is if you know the file format specification, like PDF or MP3 or WAV or some other format, you can generate files on using your fuzzer and then try to feed that as an input. And evolutionary is something that the fuzzer will identify new parts and make it even better while the fuzzing session progresses. So that's the primary difference. Mutation based, it's this is the last, by the way, this is the last theoretical slide. The only reason I had to do this was I need to give a start. So little or no knowledge, you just modify the bytes, and blocks and feed that to the target. You don't need an initial setup. Code coverage is only dependent on the inputs being modified and also on the fuzzer if you're running it for long, but it doesn't give you a lot of code coverage. So yeah. So today's fuzzer, we're going to be talking about AFL, American Fuzzy Lop. It's a fuzzer by a former Google security researcher, and it's one of the most famous fuzzers in the market today. It's evolutionary, like I specified before, the categories. It is able to instrument the target, and what is that? Is what binary instrumentation is basically that when you're compiling, You're trying to figure out all the code paths that the application provides, and that helps the fuzzer understand as to where all it can reach and what all it can do. So it generates new inputs, like I said before, feedback driven. That's evolutionary, and based on that, it will give you even more code coverage. It's very easy to use. Despite being an evolutionary fuzzer, it's very easy to use and no complicated setup is needed. We'll be just seeing that in a few moments from now. So you might be thinking that this isn't a theory class, right? Well, it's not. And from here on, it's just going to be workshop, and you guys can just follow my lead and you can practice on the virtual machine. So let's jump into a fuzzer for today. That's AFL. What do you guys have right now? If someone can answer. Also a wake up check. Free time, the VM. Yeah, yeah. So Mega is right. You have the virtual machine and only a Kali VM, right? But that's all you need. We don't need anything else. So if you have imported the OVA file and booted up the Kali image inside VirtualBox, you can just log into it using the username student and the password as pass. Let me know if you guys are able to do that. Only then we can proceed. Otherwise, it makes no sense.
We've been trying to guess password since yesterday, so this is so easy. Just four letters.
Yeah. You could have, if you wanted to brute force it, you could have during the bootloader, you could have just booted up in bin bash and changed the password. But yeah, so yeah, so this is student and pass. Have you guys been able to log in? At least a few, 4, 5 yeses would be great. Vishnu,
I
yes.
was able to log in. Yeah.
Salat. Okay, awesome. So the target for today, by the way, is LibTiff. It's not a library that is obscure, though I wanted to target something like that, but I thought it would be better to target a library which is well used, prominently used by all the softwares that we use today. So yeah, so let's begin. So this is the virtual machine. I'm going to be doing it along with you guys, so you guys can also do that. You guys can see the Kali VM right now, right? My Kali VM.
Yes, we can see that.
Awesome, awesome. So just change directory to downloads. And over here, you'll see that there are 3 files, AFL plus 2 zip files and 1 tar.gz file. So what you can do is, over here, you can just extract those files using these commands, tar xz zxvf for the tar, unzip for the fuzzer, and unzip the seal files. I'm going to be doing it, so I hope you guys can also either see the presentation or see the screen right now while I'm doing it. And yeah, unzip first, AFL. Okay, now
Hey,
that is,
Kushal,
yeah.
if you have any questions, we have to wait until the end, or can we ask you as we go through?
No, go ahead. That's what I want to make this interactive as much as possible. So provided
So here is my
it's
first question.
provided it's related to this and not something which if you're trying to skip ahead. Yeah, go ahead.
So why did you choose AFL Plus for the fuzzer, for the tool?
Right, very good question. So AFL, the fuzzer by the former Google researcher is pretty old now. It's almost 4 years now. Uh, the older version, many times it does not support the current platform that you're using. If you noticed, I'm using Kali 2020.1b. That's the latest Kali image that is provided on the Kali website, right? So, and because it's the latest image, it might also have latest versions of the compiler. There would be GCC 7 or there would be CLang 8 or something like that. So many times, if you want to, and also the TIFF library, that's also latest, a 2019 November release. So the purpose of using a recent AFL fuzzer, which is recent by the way, and that has all the other folks built into it, all the other community patches. So that makes it even better. And that is the reason, like you're testing the target, the latest version of the target. You're testing the thing on a latest machine, OS. So why not use the latest fuzzer? Otherwise, you might run into some of the other problems if you're using an older version of the fuzzer. So I hope that helps.
So to the target today, is it like a application or is it some kind of a executable or something that
So
we are running this fuzzer on?
I guess the application, you said application or executable, that's one and the same thing, right? So
Yeah, I mean, it's the same thing. Never mind, but yeah, just saying, just asking like, what is the target for today?
yeah, so the target is going to be one of the things. I'm going to be coming to that. So if I'll just proceed and you'll know in a few minutes, in a matter of like a minute or 2 minutes or 5 minutes, the target.
Can hold my horses.
It's going to be one of the binaries inside TIFF. That's obvious since we are building TIFF, LibTiff, right? So it's going to be one of the binaries inside that. But which one? I'll just come to that. So okay. So you guys have extracted these three. Yes, yes, yes. Few more yeses, awesome. Okay, so the TIFF files master, that's just the seed files which we'll be using. We don't need to worry about that now. The TIFF hyphen 4.0, that's the library which we have extracted, which we will be building. But before that, we need to build the fuzzer as well. So if you just go inside AFL master, we'll be building the fuzzer now. Okay, so so yeah, so all you need to do is you change directory into that AFL plus plus, and you just do make all. That is it, and then you do sudo make all. So I'm just going to be doing it. Uh, this I am inside the AFL uh, plus plus. I just do make all and give it a minute or 3 minutes, and then it's going to just finish building up the fuzzer. And then we just do sudo make install to make the AFL fuzzer binaries available system wide. So that's done. Sorry, there was some message. What was that? Can you push the sliders lag in case we're lagging behind? Sure, I can do that, but I don't want everyone else to also skip ahead. So you guys can just follow, and if not, then we can go back. I can go back to the slide also in case you want that. I just replied to Mega. So yeah, okay. Username is student, password is pass. So we just did make all. We just do sudo make install. It asks you for the password. We just do pass, and now we have the AFL binary inside the user bin. So it's inside the user local bin. Okay. So you guys have done this, right? You built the fuzzer, make all, and sudo make install. That's all that's needed. Yeses, please. Or an audio, yes. Okay, okay. So yeah, awesome. So now we built the fuzzer, right? Now we need to build the binary. So what we'll do is we need to build the target. So yeah, okay. So you just go inside the TIFF folder. That. So you when you're inside the TIFF folder, you can see that there is a configure file. Okay. So this is normally a typical C installation method, and you can actually see what all options are there inside this configure file. So what we do is vim configure.
Hey Kushal, so there are two TIFF folders. So we have to go to the TIFF 4.1 folder.
4.1.0. Yes, that is the 4.1.0 version of LibTiff. That is the downloaded one. Yes.
Okay, because there is one more TIFF files master folder that we extracted, so I got confused.
Right, but you might be able to see in the screen. I'm inside the TIFF, right? So vim configure. We just want to see what all options the library provides us if you want to compile this library, right? So if we do -c, okay. CC. Skipped it, I guess. Yeah. So over here, you can see that there are all these options, CC, C flags, and all these things that are available to the configure to use. So if you want to build the library using a custom compiler, you can use all these options. You can use a custom compiler using CC. You can use a custom C flags using C flags. And there are other things as well, LD flags and all that. But basically, we need to see which target we are fuzzing, what all options it gives us. Only then we need to apply that when we are building the application. Okay. So what we'll be doing is show you guys. So we'll be using these commands. Export CC. I'll be explaining these commands in the next slide. But for now, you can just use these commands and just type this inside the command prompt. That's it. That's all that's needed. Don't go to this. Just do till here. AFL harden and equals to 1. Okay. I guess most of you guys have done this. So next thing we need to do is I haven't done it. I've done this before.
Is a tab working for you? Because we couldn't autofill on the Kali when we tried. So I had to type all those manually.
So autofill normally works if you are giving us some space before that. If you give a space before that, then the autofill will work most often. Or maybe it's disabled in this version. Yeah, maybe it's disabled. I don't know. As long as you've done it, it's fine, right?
Yeah.
Don't worry, we don't have much. Oh no, we have some, so that's fine. We have time.
Hey, Kushal, quick question. When we exported it to, we untarred the file in the downloads folder, did we have to copy that folder to on the root home students? Because that's the path we are giving in the export.
Sorry, so what? We don't have to copy any files. When you open up the system, so I'll just do a recap. You guys opened up the system, you just opened a terminal. After opening that, you went to downloads. In downloads, you just did tar extract, unzip, unzip. That's it. And after that, you went into the fuzzer, did make all, and you did sudo make install for the fuzzer. After that, you went into the TIFF hyphen 4.1.0 folder, and you just type these commands. So I guess I'll move on because we've been here for quite a while, and many folks are already done with that.
But we've set CC to some path where the folder doesn't exist. Right? AFL doesn't exist under home student.
It will exist in the home students downloads, right?
Oh, okay, but yeah, in the presentation you mentioned home student.
I'm sorry. My bad. Home student downloads, but yeah.
Okay, so we have to change that. All the export commands.
Kushal, I think it's just downloads. It's not home student downloads.
It's a tilde downloads, right? Like basically it's pointing to the.
So present working directory, home student downloads. If I change that to AFL, home student downloads, AFL++ hyphen master.
Okay.
Yeah. And if you don't want to do that for home student, you don't need to. Over here, I have done, if you see my screen, I have done AFL CC equals to AFL CLang export. Why did I do this directly and not the whole path? Because I did the sudo make install, right?
Mm-hmm.
So the system, this binary is available system wide. I don't need to explicitly give the path.
Yeah, thanks.
Awesome. Sure. So we have exported all of this. We just do print env, print environment command, and we can see all of those environment variables which we just set. Okay. So you see C flags, CC, CFA, CXX, and all those.
When we exported, we had home student, but we missed downloads before AFL++. So do you want us to change those commands back to like home students download?
You can just do export CC equals to AFL CLang. That's it.
Okay. Okay, I'll do
You
that.
can do export CXX equals to AFL CLang plus plus. No need for the path. Like I said before, because the path is already, when you did sudo make install, this is already available system wide. You don't need to give the path. What was in the folder in the path is copied on the system in user local bin. You don't even need to give that path because it will automatically take that. Okay.
Got
So,
it.
okay. So we did all of those. AFL harden was also one other thing which I did. And after that, we just need to now build this. We need to build the TIFF, right? All those environment variables are in this terminal screen. So it's irrespective of where you are, it's available. Okay. So what we do is we just do configure disable shared. Configure dot slash configure backslash disable shared. This is very important. Don't forget disable shared. Hyphen hyphen disable hyphen shared. If you don't do this, it will not work ahead. So please make sure you do this. And press enter. That's it. So we did sudo make configure disable shared, right? And after that, we just do a simple make. That is it. So you do make command. By the way, over here in this, you can see the library is telling us that, okay, we are using a C compiler. What is a C compiler? AFL CLang. What are the C flags? We are using address and undefined. The C++ compiler is AFL CLang plus, address undefined, installation directory user local. Okay, so and what all it supports? It supports Pixar, LZMA2, WebP is not supported. So all of these no and yeses are because those libraries are not installed on your system. If you have those, then they will be supported as well. Okay, so that's that. Just do make now and wait for a few minutes. Okay, so just do make, make. Over here also you can see that the binary, it's if I just yeah, I'll just go scroll up so that it doesn't go down. We can see that it is instrumenting some locations. It is 64-bit hardened because we did hardened mode. And it shows us, okay, F sanitize address undefined. So whatever flags we set are being used, okay, for this. Now, I'll just explain what exactly sudo works. Awesome, awesome. So what exactly did we do out here? By the way, you can build with using AFL CLang fast. That's the LLVM mode, and that will be faster, and it gives you faster fuzzing and a little bit of different code coverage. So yeah. So what I did was I just did this, and we have done the make. So it is building now. It will take a few minutes, 3 minutes approx. I timed it once, and it should be good after that. So what exactly did we do, right? That's the main idea. Running some commands, it's very simple, but why is the main reason. So all the export commands were basically AFL related environment variables. And we set that up so that if there is some cross compilation or something, many times I've noticed that the configure file, when you push that command, the C flags and all that, the configure, it might open up some other configure file from somewhere else also. It might reference something else. So in that case, it will not work. So that's why environment variable is the best thing. And that is the preferable way. CCCXX are the C++ compilers which we have set for our target. And C flags and CXX and LD flags, LD is linker and CXX is for the C++ compiler, C flags is for the C, are the compile time flags we use. And we use, in that we give F sanitize. This is address sanitizers. These are sanitizers. You can look it up on GitHub. Basically, they help you identify more bugs which are not identified by the fuzzer by regular compiling. And if you compile it with this, it will give you lots of bugs. Yeah, so there are different kinds of sanitizers: address undefined, memory. These are the three well-known ones. Um, the security researchers that I know, they have already exhausted these, but they still find bugs from time to time. And there are several other sanitizers which people don't share, but I'm going to be sharing right now, is Thread, that is still a little bit of spoken about. And there is one more which is available with the recent CLang version, that is Control Flow Integrity, CFI. And Google researchers and Google developers are currently just using this sanitizer to find more bugs. Recently, it's not as old as the other sanitizers, and they find a lot of bugs. So you can use those as well. Now, yeah, by the way, this makes your target application slower, but it's at the expense of finding bugs. So it's up to you what you want to do. Yeah. So we just did configure, we did make, and now we want to see what did we build, right? So you must have got an output like this: nothing to do, nothing to be done, right, guys? Yes. A few more yeses, please. Few more. Okay, awesome. So basically, the target has built, and okay, awesome. Thanks, Jonathan. Thank you. So I don't need to worry about that. The target is built, and now we just want to see what did we build, right? So I'm just going to clear screen, ls. I don't see anything out here. Okay, so if you just head over to the tools folder inside TIFF, cd tools, and do ls, you'll find a lot of so a lot of applications over here. There's something in white and there's something in bluish green. It's cyan color. So yeah, it's kind of green. So the white ones are just the files, and the green ones are the interesting ones. Those are the applications. Those are all ELFs, ELF binary 64-bit. That is the application executable. So we are going to be using one of these. There are some which offer you the capability of converting files from one format to the other: fax to PS, or that PS is PostScript; fax to TIFF; PAL to RGB. That's a graphic format. RGB is like red, green, blue something, and PAL is PAL mode. Uh, PPM is another format, raw to TIFF. So these are all the ones which are providing from here to here is from something else to TIFF. And then from here onwards, TIFF to BW, it goes on to build something else, convert to something else, a TIFF file to something else. So we are going to be focusing on these because we have our input files as TIFF files. So we need to only convert that to something else, right? So going back, so yeah, so that's what we built. We built all these binaries, and now we want to we just select one target from this. So for our presentation, we're going to be using TIFF to PDF. Okay, we're going to be converting TIFF to PDF format, and that is available over here, TIFF to PDF. Okay, so let's create 3 directories and copy the input seed files into that. Okay, so going back, cd dot dot cd dot dot, get back to the downloads folder. Okay, get back to the downloads folder. Over here, you just create 3 folders. Sorry, make dir, make directory, TIFF to PDF in, TIFF to PDF cmin, TIFF to PDF out. If you want, you can only do in, cmin, out. No need to give such long names. The only reason I gave that is for explaining, so that it becomes it's easier to understand. But you can just do in, cmin, and out. Okay. So make directory and that. Once you have done that, you can just copy whatever is inside of the TIFF files master. Remember that folder which we haven't used yet. So that folder has a lot of TIFF files. So we just want to copy the contents of that inside the in folder, TIFF to PDF in, or just simply in if you have used in. I'm also going to be doing that. I'll just do the same way as what you guys have done. Okay. Make it easy. Make dir in, cmin, out. Simple. And once you have done that, you have 3 folders, in, out, cmin. Now you copy all the files from TIFF files underscore, sorry, files master. Everything inside of that goes inside the in folder. Once you do that, you do ls in, you have a lot of files inside of that. Interesting question. So where did I get the input files? Where did I get it, or where do we get the input files for this fuzzing session? Okay, yeah. So I generated few. I borrowed from somewhere else, but I borrowed from several places, and there are many which I haven't even borrowed yet. So this is just a subset of whatever corpus I have gathered. Okay. So have you guys done this? Created 3 folders, copied all the files from TIFF files master into the in folder.
Yes, please.
Awesome, awesome, awesome. Few more yeses, please. Guys, let's stay awake. It's not 8 yet. It's still early. Yeah, good question, Mega. So the TIFF over here is tagged image file format, the TIFF file format, the images. Many times if you're using some cameras, they have TIFF. That's what it used to be before. Now even the regular iPhones. Yeah, sure. So yeah, TIFF files have been copied. Now we need to do, we see that, okay, how many files are there in the in? There are 410 files. That's a lot. So, and many of these files would also be having the same path which the application would come across. So we need to reduce the corpus. This is called as corpus, corpora, people, yeah. If it's a lot of corpuses, yeah. So, what is the purpose of these 3 directories? Yeah, let's first see that. So input is basically all the seed files. Okay, that's containing all the files. The cmin folder is the corpus minimization, cmin. So that's going to be reducing the corpus files. Out of the 410 files that we have inside a input folder, we'll be reducing that to a few lesser number of files, and then we'll be fuzzing only on those files. And the out folder is basically where the fuzzer will store all its data, whatever it generates, whatever crashes, whatever hangs, whatever queue, whatever new parts. Where is it currently stopping? If you're stopping the fuzzer, where is it currently stopped at? And all those things. What is the command used and everything. So that is the output. That is the purpose of these 3 folders. Okay. So we created the three folders. I explained it to you guys. Now, before we do go ahead, let's check what is TIFF to PDF. What all options it gives us. You need to make sure that you check all of these, because especially in this case, because you have TIFF, which is one format, and PDF, which is another format. And PDF, as you guys know, PDFs it's now 2.0, but they have a lot of versions. So a lot of options you can do, a lot of things you can do in PDFs, and similarly for the images as well. So I showed it in the image, but I can just show it to you over here as well. CD TIFF 4.0, CD tools, and you have TIFF PDF. So it shows us, okay, there are so many options. You just want to, how do we use this tool? First of all, we just use the binary, give some options, and then give it some input file. Okay. Options can be you want to output it to some other file name. So the output PDF will be saved somewhere at some location with some name. You want to compress it with zip or deflate. That's the two compression methods that there are several compression methods that PDF format offers us. So these are the options for that. Do you want to invert the colors? Do you want to do something with the images? A lot of things. And then you have the PDF formats or PDF options. So there are some options for the image format. There are some options for the PDF for the output format, but you have a lot of options and you can use either of them, any of them if you want to. So for our case, we just be using the -o output file name, nothing else, nothing fancy. So because we want to make sure that if we do this, this is also working in some other applications as well, which I'll be coming to. So the fancier you make, the unique, the more unique the crash is going to be only for that particular library. And the less fancy you make it, the chances are of that crashing something else are higher. So I'll be coming to that later, but yeah, but that's a very big thing. So we have a lot of seed files. We want to minimize our corpus. So we just use AFL cmin, this command, and we use this command, and that is it. That will reduce our input files to a lesser number of files. So you guys want to just type this in. By the way, if you're typing this, just type this from the downloads folder. Okay, don't be in some other directory and expect it to work, because we are not giving the full path to the TIFF to PDF in or this. So it's a relative path, so it has to be inside of downloads, wherever you have created these folders. Okay, guys, okay. Awesome. So you guys can just type this command and yeah. What's the goal of minimizing the corpus? Great question, Miguel. So, Miguel, the answer is that if you are fuzzing and it's kind of a dumb fuzzing, because we're just going to be bit flipping and buffering, even though it's feedback driven. But the chances are that if you have 10 files, out of which 4 files are just going to be covering same code, same paths in the application, then why do we want to fuzz 4 files? Why don't we just fuzz one file, right? Out of that, and save up on our executions and save up on our output. So that is the purpose of minimizing the corpus. Does that answer your question? Okay. But don't you need to run the inputs to know that? Exactly. So that's what we're doing right now. We're just using the AFL cmin, and what it will do is it will run all those files using the AFL fuzzer against the binary, like you see over here, TIFF to PDF, this exact command, and it will tell us that, okay, which files are selected out of that, which files do we not need, and only the ones that we need will be saved in the cmin folder. Does that help, Miguel? Or you have more questions? Awesome. Narrowed down to 158 files. Oh, you already hit enter also. Awesome. Okay. So let me do that too, so everyone can just follow. So yeah. Oh, first I need to get out. So getting back to this, AFL cmin -i in -o 165 files. Okay. Out. No. Output is cmin. Dash m none. Give the whole path for the target. F dash o null and @ 161 I think is the output I got, but let's see. Yeah, 161 was the output I had got, but let's see what it should give me the same output. Maybe I don't know. Oh, tuples have changed. 1087 tuples. Interesting. It was 1085 tuples. Okay. 160 files. I got it. So that's fine. It's weird. Maybe depending on the system or the platform. I don't know why this changed, but this is something that we can investigate. But yeah, so you got some files, okay? And basically we had 410 files before. Now we got 160 files, which has reduced, right? Now all we need to do is run the fuzzer. Okay, we have reduced the corpus, we have our input files, and we just run our fuzzer. So you don't need to type the whole command again. All you need to do is change AFL cmin to AFL fuzz, input dash I to cmin, output is folder, output is out. That is it. So I'll just show you the command. Don't type, please don't type it again. So yeah, I don't want you to guys. That's the purpose of fuzzing. We automate it. So yeah, so AFL fuzz instead of AFL cmin, we change that. Input is now cmin, output is out. Before input was in, output was cmin. Now we have input as cmin and output as out. Okay, that's all. No other change. Just going to keep this so that you guys can type it and run it. If you want to press enter, you can hit enter and start the fuzzing session. If not, then you can wait for me to also do that, and I can also do that. But I'll be doing it after you guys have at least copied the command. So we don't want to clog up our memory space and also spend time saving the file. And for that reason, we just push it to dev null. That's like outer space. It's nothing. So into nothingness. So that will reduce the question, the processing time and writing to file and the file handlers and all that that's involved, and also increasing the speed. So okay, so your question, it's a question. Okay, so is the option for TIFF to PDF? Yes, that is the option. If you see TIFF to PDF -H, the help option, it shows you what all options are there, right? It gives you -O, and that is the output. And so we just use that -O, and we use dev null for the location of that file, the path, which is nothing. That's it. Dry run, Mega, good question. So dry run is basically a very good thing. The purpose of a dry run is many times researchers they have such interesting test cases that before even starting the fuzzer to find vulnerabilities, the seed files itself might be vulnerabilities in itself. So if you just do the dry run, you'll identify, oh, does the application just crash with this input file before even starting the fuzzing session or not? Also, it will also tell you if it takes a lot of time, how much time it takes to process that in milliseconds. If you just scroll up, you'll see 2000 milliseconds, 3000 milliseconds, all those. So that helps you identify, is the target heavy? Is this file only the one which is taking too much time to process? If I remove this file, my fuzzer will be faster for the other files. So that is the purpose of the dry run. So I'll just run the commands because I gave you all time to do that, but I didn't do that myself. So let me just do that. Fuzz -cmin, change it to out, and we should be good to go. Okay. Yeah, so you see 13, this is showing me, I don't want to scroll down, stay here. So this is showing me 1399 microseconds, right? This is execution width. This is just 5335 microseconds. So this way I know that this file is taking a long time to process. This is taking a negligible time compared to this, and that helps us if you want to be selective in our fuzzing. Okay, Vega. So that's just something I wanted to show you guys. So it's processing, it's processing. Yeah, okay, good thing. So you'll see the fuzzer. It's interesting. Yeah, now it comes to the good part. Just 7 seconds, right? By the way, are you guys also seeing this? How many executions are you guys getting per second? Can you guys just write? Approx 6, 10, 300. Alex, you have a fancy machine, I guess. Or maybe you gave a lot of RAM. So yeah, so basically this shows me only 5-10 seconds or something. It keeps on changing, by the way, but it's very less. It's showing me zzz. That is a fancy sleeping gesture that the fuzzer gives us. So yeah, so basically we see that it's a small thing. It's a very slow fuzzing session, right? So if you guys just scroll up in the terminal, you'll see that the fuzzer tells us something. Do you guys see this? Some test cases are huge, 942 KB. Guys, a few yeses, please. Okay. So you guys notice that the file is big, right? There are some cases which are like 942 KB files. So because of that, our fuzzer is slow. If we reduce it, the fuzzer itself tells us. We don't even need to, infer this on our own. It tells us some test cases look useless. Consider using a smaller set. Some have huge files. So there are some performance tips, which if you read, will tell you to reduce it using AFLT-min. But right now, what we can do is we can just remove all those files. When this fuzzer was first built 4 years ago, AFL version 0.1 or something, at that time, the fuzzer was only meant for files which are less than 10 kilobytes, 10 KB. And now it supports less than 1 MB or something like that. So 10 MB or something. So what we can do is you can remove all the files. By the way, this is an optional thing. If you guys want to do, if you're satisfied with this, then yeah, if you want to do, you can do this as well. So what I'm going to be doing is I'm going to be removing all the files which are greater than 10 kilobytes and then rerunning the cmin and fuzz command, both the commands. Okay, but before doing that, I'm going to be stopping this fuzzer, clearing out the cmin and out folder, and then starting over. Okay, so stop the fuzzer. Okay, we clear out everything inside of cmin, clear out everything inside of out, also the hidden files .car input. We remove all of those, and then what we do is we delete all the files which are bigger than 10 kilobytes. Not this, we just open the in folder. That is our source. We'll just play inside of this. So you see there are a lot of 942, 500. So anything greater than 10 is out, delete. We just have 238 files now in our input. Okay, so if I do ls input word count file 238 files. Okay, so now all I'm going to do is just run the fuzzer again, run the cmin and then the fuzzer again. Okay, but this time with the files which are reduced. Now it's no longer huge files, it's only less than 10 kilobytes. but the tuples are the same. Interesting, right? Still the same number of tuples have been reached. So it's very dicey. Like, even when we removed those extra files, our fuzzer is still able to come across the same number of paths. So we have 82 files. All we need to do is run the fuzzer again. Guys, you guys saw what I did, right? So right now you see the fuzzing execution speed has increased. Before it was 710 executions per second. Also, the execution timeout that the fuzzer uses is now 40 seconds. Before it was 500 milliseconds. Now it is just 40 seconds. So our fuzzer has become faster because we reduced those extra heavy test cases.
Yeah. We remove the extra heavy text cases, but we are still getting the same tuple number. So which means we're gonna add the same results with less and small files.
Yeah, and faster, much faster. Actually, the results what we get will be faster. If you would have used those heavy files, you would have gotten some crashes maybe 30 days from now. But if you reduce the files, you would have gotten the crashes maybe 10 days from now. So that is the difference. Because of the execution time, like you see over here, 40 seconds, that was 500 seconds. Because of that, the fuzzer will wait only 40 seconds for each operation, for each execution. Because of that, it is able to run more executions. And also the RAM and everything where we are supporting whatever is the infrastructure, all of these factors come into play in this.
Hey, Kushal, can you share the commands again for the next steps that you did?
Okay, no fancy commands, same commands. All I did, I removed the contents of Simin folder and out folder.
Okay. And let's run again.
And then after that, I deleted all the files which were greater than 10 kilobytes from the input folder. So basically, before we ran those corpus minimize and fuzzing, what did we do? We ran those commands, right? Those folders were empty. They had nothing in them. Once we ran the commands only, then there was something created inside the sim in and out, right? So if you're going to rerun them, we need to clear the contents of those folders, correct? And since this time we are, yeah, I will share that Caltech, sure. I'll share the history. Just give me a second. So I just want to explain. So since we are reducing the files, we need to delete the files also, right? From the input folder. Okay. So I'm just going to stop my fuzzer. You guys can see the difference over here, see the difference over here. So good suggestion, Caltech. I'm just going to do history and you guys can see. So you increase zoom in, control plus plus. Does it work? Zoom in again, control plus plus. So, does it help now, Caltech? Awesome. Thanks to you. It was a nice suggestion to zoom in, sorry, to show history. So, RMRF, Siemens, everything inside. RMRF out, everything inside. But even if you do star, it will still have one hidden file, cursor input. So you can remove this also manually. Okay? But don't delete the folders, mind you. Don't delete the output and Siemens folders. Keep the folders, only the contents inside of that. Slash everything inside. Okay, backslash everything inside. And then after doing these commands, deleting everything, go back to the input folder in your GUI and delete all the files. I'll just show you. Downloads in open folder. And I do view detailed list, size once, size twice. We have all the files which are in a ascending or descending order by size. And then just delete all the files which are more than 10 kilobytes. Okay. Basically, we are reducing our heavy files, removing the heavy files. We don't want to deal with them. We want to make our fuzzer faster. Okay.
Okay.
So yeah, I'll just go back to the presentation. Yeah, that was the fuzzing command. Output slow seconds, sad output. Yeah, we saw that. We removed all the files, made it a little bit better, tried to make it a little better, a little bit of better execution. And yeah, so that's what we did right now. There are a few other things. I just want to show you guys. It's not in the presentation, but I just want to show you guys. Okay. Um, there is one more thing that AFL gives us, one more option that AFL gives us. You have something called the quick and okay, 1 minute. First, I'll just show you guys the fuzzer so I can explain this. Run. Yeah, start and stop. So over here, you can see it's doing bit flips, right, guys?
Yes.
Okay, so that's just flipping of bits and everything for each of those files and everything like that. And then it will do byte flips. Over here, as you see, fuzzing strategies, bit flips, byte flips, arithmetics, known integers, dictionary, havoc. Many researchers make a mistake that they just use the simple fuzzer, you know, bit flips and byte flips. But the problem is that bit flips and byte flips are not going to make a big change in the file. It's just going to be changing a few bits here and there and seeing if it crashes. The actual good value for money is going to be in the dictionary and havoc, especially in the havoc, because havoc is going to do, like the name suggests, havoc, chaos is going to go crazy. So this is something that we need to do. But the problem is that the fuzzer will first do bits, then do bytes, then do arithmetics, then do known integers, then it will go to havoc. So if you want to directly skip all the bit flips, byte flips, all the all the academics and just go directly and try to be street smart, you can just use havoc directly. All you need to do is add one option, -d. So I'll just show you. AFL fuzzer gives us an option, -d, behavior, quick and dirty mode. It skips all the deterministic steps that the fuzzer uses. So you can just do this -d and it will only give you output in the havoc mode, and that will be way faster. Way faster, maybe, maybe not, but it will be way diverse. It will give you a lot of code coverage. And yeah, that is the best part about it. So all I do is, and by the way, this option is only in the fuzzer. Don't do it in the Seaman. Okay. Everything else was the same, but only for this, we just use -d for the fuzzer. So now you see it's only going directly into havoc. All of this is not applicable. It doesn't bother about all this. Bit flips, byte flips, who cares? I'll just do havoc. And I'll get more paths in a short period of time. Guys,
Where do you see the path and number
over
of
here,
paths?
total paths on the top.
Okay.
Right? So it's covering up more paths in a shorter period of time because we skipped all the deterministic things and we just directly went to havoc. We just went, batshit crazy. So that's one way to go about it. Other thing is that, like it shows over here, dictionary. So AFL is a very good. Till now, people say that it's evolutionary because it's feedback driven, right? But it's still at the end just a dumb fuzzer. The fuzzer does not know anything about the file format. It just fuzzes blindly. Okay, but there is an option to make it smart. So what is that option? Is dictionary. So like the name suggests, dictionary, it instructs the fuzzer about the file format. What is the format about? What all things can you put inside the file when you're fuzzing it? Okay, so AFL gives us a lot of dictionaries by default, and you can also create your own dictionary in a text file in any file and save it, and then use that for your fuzzing session if there is no publicly available dictionary available for that format. Okay, so what I'm going to show you is that AFL++, if you see inside the AFL++ directory, you have one folder called dictionaries. you have all of these dictionaries over here: GIF, HTML tags, JPEG, TIFF, JSON. You have also have TIFF. So if you see TIFF.date, you have all of these dictionary values for the TIFF format, which you can use. It is just telling us, since it's not a a compounded format. It's just a simple format. It just gives you hex values, header values, and all those footer values and all, right? So, but you can use this. This makes your fuzzer smarter. All you need to do when you're fuzzing is give one more option -x and the path to that directory, to that dictionary. Sorry, wherever is the dictionary, you just give the path using #x, and it will use that dictionary for your fuzzing session, which makes it even smarter. So that is one option you guys can use. And there are a lot of other options, but these are the most common ones that folks use and they fuzz. So that's the dictionary mode, and that's the havoc mode, the dirty mode, quick and dirty. We saw that it gives us much faster output, much faster crashes. Sorry, paths, more paths in less time. Yeah.
What does it do in havoc mode?
Like it said, it skips all the bit flips and byte flips and arithmetics and all that. It just directly goes mad. So there are a few things. If you read the documentation, it would take me a lot of time to explain. But if you read the documentation, it will explain like what is Havoc exactly and what it does. But one thing's for sure, if you want to, skip the documentation, the RTFM, then what you can do is you can just think that it's what do you say? How can I say this? But it's not going to be learning 1, 2, 3, 4. It's just directly going to 100. It's like that. Yeah. In lame, simplest way to put it that way. So by the way, guys, this was what we did. The one purpose. How many? Let's see how many guys. Oh, folks reduced. No worries. They're lost. They must be learning something else. But yeah, so the reason I showed this to PDF is because there is currently a 0-day in this, and same version, same application, which we just fuzzed, which we are just fuzzing, and the same command, and it gives us a heap buffer overflow in this. I haven't shared the exact path and everything. If you can make out from this, then great. But if not, then yeah. But basically, what I mean to say is that you guys can still fuzz the same binary, get a vulnerability, not just a random crash. This is address sanitizer. Our fuzzer will also give us this because we used fsanitize equals to address and undefined, and you could find a bug in this same product, and in the current version, by the way. It's not an outdated thing. This is the latest version, same product, some input given, which causes the crash. So just want to show you guys that it's not something that's outdated knowledge or something that's not applicable. You guys can apply and you can get a CV vulnerability or what have you for that.
So, Kushal, uh, so did you submit the CV for this one?
I didn't find this.
Okay.
Yeah.
I have a couple of questions for you.
Sure.
So, when this fuzz is running, you are going to havoc mode and everything, right? So,
Right.
how do you change the mode? Like, do you have to press any like -H or something, or how do you change the mode
So
when it is running?
when the fuzzer is running, you can't change it in between
Okay.
because you need, if you're fuzzing using a strategy, you need to stick to that strategy. And but there are several ways you can go about. If you're using master slaves and all that, you can have one fuzzer with AFL CLang fast, one build with that, one build with AFL CLang, one with GCC, one with sanitizer, one without sanitizer, one with another kind of sanitizer, one with dirty mode, one with this. You can have multiple ways to go about it, running simultaneously as a master and slave, and providing output from one to the other and from other to the other like that. That is possible. If you have a lot of cores, you can do that. But what you can't do is once you start fuzzing, after 20 minutes of time, you can't change in that same output directory, you can't change the fuzzing command.
Okay.
It's not recommended because then that would be crazy. So that's one thing, right? So this,
One more question for you would be, how did you get this output? Like, what are the buffer flow you're showing right now?
there are ways to go about it. I found some POCs and I just tested and it worked.
Okay.
And sometimes I fuzz and I find. I don't even remember where I found this in my hard drive or wherever I found it. But because many times, like people are, they have a lot of files, but they don't even know which version. Like I'll give you I'll give you an interesting thing which I saw. Many times when I was fuzzing version 4.0.4, almost 2 or 3 years back, something which did not crash then crashes now, which is very interesting. So the one thing that you need to do if you're a researcher, if you're fuzzing, if you're into this, never let go of your files that you generate. Never let go. So I'm going to come back to that in the coming slide and give you one interesting thing, which I also told Silhat about. So what do you do next? So there are several things you can do. You can test the crashes directly against other softwares, libraries supporting this format, and you can, maybe find a bug in that, security vulnerability in that. You can wrap the crashes inside of other formats, like a doc file, a Excel file, a big presentation, or a PDF, and test softwares which run doc files or PPTs or PDFs. Basically, you can test other targets by wrapping this TIFF file inside of another compounded kind of a wrapper file. Okay. Or you can also test the queue, not the crashes, not the hangs, but the queue. So the queue is basically all the paths that you generated that you came across, but they are not crashing the application, but they are still valid TIFF files, almost valid TIFF files, and you can use those as well. People don't use this, people let go of this, but this is something where they miss out on a lot. So that is another thing that you can do. Now, other very good interesting thing, which I'm not sure if Silat is with us on this talk right now, but I remember we had a discussion during his presentation a few months back, and so basically in this, what I mean to say is there are two ways that you can go about. You either find one POC and you can get 100 tested on 100 targets and get 100 vulnerabilities, or you can test one target and you can get 100 POCs on that. It's up to you what you want to do. People, if you're targeting something, if you want to fuzz something which has never been fuzz tested, you will try to find a bug in that, and because nobody else is looking at it or hasn't looked at it for a long period of time or never, you will find a lot of bugs in that. And the other thing is that you just find one POC and you test 100 targets. That's a smart way of going about it. And the second approach, the one on the right, is the hard way of going about it. So the smart way is beneficial at times because you found a vulnerability in this TIFF to PDF, the this library which I just showed, right? In this one, maybe the developer of this library is not interested. So he'll be like, "Nah, who cares? I don't care about the vulnerability. Let it be." But that same vulnerability could be of impact in Google Chrome. And Chrome would be like, okay, we need to fix this. So if you test multiple targets, there are chances that someone or the other will take the initiative to fix it. And therein lies your chance to be credited and also to feel that, okay, you have contributed to making the world a little bit safer. So that's two ways that you can go about. So what do we do today? We learn to use AFL, build and fuzz a real world and prevalent library, LibTiff. We notice there are several ways to build an application. I haven't shown GCC right now and LLVM, but those options are also there. I can share that later offline. But CLang we use, and we also saw all the different compilation options, sanitizers, address undefined, and that what impact it gives us. We saw that okay, crashes and vulnerabilities are often dependent. You guys noticed, right? You guys saw different tuples, number of tuples when you were doing the corpus minimization. So many times it also depends on environment or hardware or something or the other. So in this case, especially for the when you're fuzzing, the OS is something that is important, the operating system. Sometimes it works on Ubuntu 16.04. Sometimes it doesn't work on 16.04. It works only on 14.04. So many times the environment is important. Also because it uses different libraries, different system libraries. Unless it has a preset list of libraries which it also builds and saves separately and uses statically, that's a separate thing. But otherwise, it also depends on the OS. Also, the compile time options, that is a big factor. Sanitizers or no sanitizers, linker flags, all those things. Which compiler you're using, which version of CLang are you using, which version of GCC are you using, or even for LLVM. All these things matter. And the reason why I chose this library because it gives you a lot of tools to play with. I just showed you TIFF to PDF. You guys can do TIFF to PS. You can do TIFF dump, TIFF info. There are a lot of other tools that we just saw in that tools folder. And most importantly, you guys might know this, not know this, but this library is used in all big, browsers. Google Chrome uses it. Chromium also uses it. Internet Explorer uses it. Microsoft Edge, Safari for Mac users. Even the Sony PlayStation that also offers support. And all of these are, all of these products, they consider this library as security critical. So if you find a bug in this, they want to know about it, either from the developers or if you report it to them directly. So this is the main reason why we chose this target. So any questions that you guys, I guess that wraps up my session for today.
How are we gonna see the results of AFL Fuzzer?
Oh, very interesting, very interesting. So sure, I'll just show you that very quickly to you guys. So, so we had the output folder, right? So this folder, I should have shown this. Good catch. So this folder has a lot of, the output folder has other subdirectories inside of that, crashes, you have hangs, and you have queues. So if the fuzzer catches a crash, it is going to save inside of this. Hangs, it is going to save inside of this. And the queue is basically the one which has all the paths, total paths which are covered. So what you need to do is sit back, relax, leave the machine running, let it run 1 day, 1 week, 1 month, 6 months, a year. So that's the purpose. This fuzzer is just something that you just run and let it go. HS asked, I don't know what his name is, but he asked, can we pause and resume? Good question. We can do that. If you are running the fuzzer for 20 minutes or more, you can do Control C to stop it. Come back. When you're doing that, when you're coming back, instead of the input folder, you just use hyphen for the input folder. The fuzzer will tell you if you try to do that and there's something inside, it will tell you don't do this, just use hyphen. So we don't give the -i as input and then the input directory, we just give -i hyphen blank and it will continue. AFL minimize the duplicate crashes? Yes, it does, Siddharth. Good questions here. So Siddharth, the AFL fuzzer, like it shows in the image, where is it? In the image, it shows unique crashes, right? So like the name suggests, it's unique crashes. So it's not going to be duplicate crashes. It's just going to save unique. If it comes across the same crash again, it's not going to save it. It's not going to save that. So,
What is
yeah.
map coverage?
Map coverage, it's an easy thing which I can explain right now because it's basically how much of the entire code are we covering right now? Have we covered? So it's kind of a little bit detailed, but most of those map coverage and is basically for the target. How much of the target we have covered? Paths, favored paths, and all that is basically how much of the paths of the unique paths, total paths we have covered. Same is over here. Own finds. This is like 2012 files were found on our own, and pending are 72. So each of these, if you see the documentation, you can understand. Yeah, I won't be able to explain everything, but it's very simple. So this basically the purpose of this was just to get you guys started. Like, we look at something and we are scared of starting it, but if we just dive into it, then that fear goes away. So that was the purpose. Yeah, good question. We can fuzz an application without compiling it. You're talking about black box binaries. We can do that. And only you need to use the Kemu mode for that. So you use -q, Kemu, which is for closed source or non-instrumented or, yeah, non-instrumented binaries. If you don't have the source code, then you can just use that -q. But you
Like
need to
if you
build
have an
that.
executable file, you can do that, right? Just pass that file and okay.
Yeah, but if so, it's preferred if you have the source code because your fuzzer will give you better output, faster crashes if you have the source code. That's always preferred for white box, right? But if it's black box, if you don't have the source code, you need to install the Kemu mode for AFL. And once that is when you're building AFL, and you can just use that switch and start fuzzing. There's one more option. You can also use -n, which is like the dumbest mode. It will not care about new paths. It will not care about anything. It will just fuzz and just it won't be informative. So there are two ways, but Kemu is the option, is the way to go with AFL. There are other ways also with other fuzzers, but with AFL, Kemu. So right, Windows is separate. You can use WinEFL if you want to use that. Windows has a port WinEFL, but there are other fuzzers as well. But I won't be sharing that right now over here. So this is only for AFL, for open source. I guess Nikhil asked that question. So I guess most questions are, what do you mean by path? Possible input? Well, possible input files. Yes, more files which are generated based on the fuzzer, understanding the previous files, feedback driven, right? So that's why Mega. Which fuzzer do you recommend to test protocols at layer 2 or layer 3? You can use AFL. AFL is good. You can use Spike, Sully. Bufuzz is good. Bufuzz is the de facto one that people are using these days. And but I would suggest using Scapy. Just using a Python script and Scapy, and just go crazy with that. Because when you're talking about protocols, it gives you a lot of leeway. If you're fuzzing an application, you need to build it for libraries like this. But if you're talking about fuzzing protocols, you are not tied up. You can build your own interface to talk with that particular protocol. So it will be easier to just write a Python script and use KP with that instead of conforming to the process and everything that the fuzzers give you. So that would be like you're trying to learn something and implement, whereas in that you can just start on your own. You don't need to learn the fuzzers.
Another
So
question from Alex is, can it use multi-thread?
can what use multi-thread? So I'm confused. It is very vague and ambiguous. So can what use multi-thread? If Alex can a little bit descriptive.
AFL?
Fuzzer use multi-threaded applications. When you say use multi-threaded, I mean I think you mean can the fuzzer fuzz multi-threaded applications? Yes, it can. But it would depend on which application you're trying to fuzz, and it would also depend on what like over here you saw we did disable shared, right? So many applications they give you an option static, and some of them don't give you the option static. But then if that particular it's multi-threaded and that particular library which it depends on is available, and if you're able to build that also, then works fine. Other thing is you can also disable. So this AFL fuzzer, the only reason you see all of these executions 5 per second or 300 per second is because of a fork server. AFL gives you an option to use a fork server. It forks the application into multiple threads. So you are running 300 executions on 300 different modified files at the same time. But if you want to use, and if you're doing a multi-thread application, that could crash. So that you cannot run, that could make the system unstable. So AFL gives you an option to not to use the fork server, no fork. So there are options in AFL, if you read the documentation, that you can disable the fork server, use AFL for multi-threaded applications, and it won't be as efficient as much as this one. You can see number of executions, but it will, at least it will work. You'll get the benefits of the fuzzer without its speed. Hope that helps for the multi-threaded question. So Sihat asked, have you experienced running AFL on Docker? No, not really. I haven't personally. I haven't done it on Docker, but I can do that. But I don't trust it because many a times um, I have different fuzzers using um, corpus or generated files from other fuzzers in some other targets. So it's very hard for me to keep it separate using Dockers. What I do is I just have different VMs pushing different files to different places and taking it all. So for that reason, I haven't done Docker, but I would be, if you can share some ways, then I can definitely learn that, how to use that in my current setup. Oz, coming back to you. You
It
were
was Rajesh's question. Do you have any good reference?
sure. So whose question was that? Rajesh?
Rajesh, yeah.
Okay. I didn't see him on the chat, but sure. So a good reference for AFL. Well, this session is one, and apart from that, if you just use simple Google works, there are YouTube videos that you can use. Uh, okay, reference for using AFL on Windows. Yes, there are plenty, but just search for WinAFL and you'll get a plenty of them. But there are no, directly. So with WinAFL, it's a very interesting question. I understand where you are getting to. Yeah, you're not the only person who had a hard time. Everyone else has. But the problem is, the reason is that with AFLs, basic AFL, you don't need to worry about the binary. You just right, like we saw right now. Anyone after the session, people might feel that it's so simple, it's so simple. So it is. AFL for Linux is quite simple, but with Windows, the problem is that you need to know the exact offset, the function where which you want to fuzz. So you need to do a little bit of reversing, and that would help. But without that, it will not. With WinAFL, you need to do at least open the target DLL or target executable in IDA. Just do that. Find where it starts, or if you're more specific, find out which function you want to fuzz, but at least get the offsets of the function which you want to, either the main function, either the start function, or a specific function of that binary. But you need to open it in IDA. Without that, not possible. Does that answer your question, Rajesh? Awesome. Perfect. So anything else, guys? Anytime. Anytime.
Any other questions? I think we don't have any other questions. It was a fantastic session for everybody else, and I believe the attention was so high. So thank you so much.